Hello everyone. In this video we are going to draw a very particular type of oval, dividing the long axis into 3 equal segments. In order to do so, we're going to use what is called the Talis Theorem. So, I'm going to change the color of the next line in order to draw a clearly weaker and thinner line, because this is going to be an auxiliary line. Therefore, now, I'm going to take the compass, and I'm going to choose any type of radius, for instance this one, it doesn't matter which one, okay? And I'm going to add 3 times that same radius. By the way, this angle here really doesn't matter at all. What does matter is what we're going to do now. We're going to join this last extreme with that extreme, and now I need to be very careful in the drawing of parallel lines. Parallel to what, you may ask yourself? Parallel to this last segment that we drew, and I'm going to try to at least to simulate how it's done. So this one is going to be the rail, and this one is going to be the one that's going to start sliding. Okay, so we start sliding, so it passes through the next step or stop, as you can see here, how we draw that parallel line, and we continue on sliding till it passes through the next step, which is somewhere there, and here we go. Nice. So these 3 segments should be equal, and according to that, we are going to use that fact. I'm going to change now to black again, because I need to draw both circumferences that passes through here, and it should pass exactly through that segment. So that would be 1, and here again, and it should pass through the extreme. That is not as accurate as I wished, so I'm going to, don't call it cheating, but there we go. So that would be. And now we are going to add some tangency points in order to draw the big arcs here on the upper and on the lower part. We're going to use the intersections of both circumferences as the O3 and O4. So here we go. One case, followed by that other case, and here we go. That wasn't as accurate as I wished again. So, much better. And so we are. Let's label, okay, all of the tangency points and centers. So, for instance, this would be O1, that would be O2, here we had O3, here we have O4. And that would be T1, T2, T3, and T4. So, nice. I can change the color. In my case, I could. If you have an adapter for your compass, you can do exactly the same thing. And here we go. We're going to draw, first of all, that long arc goes from T2 to T1, having the center on O4. Then an O1. We're going to draw this full arc, this little arc. Oh, that wasn't accurate at all. So let's repeat it till we get it. Well, then we go again to O3, and from here to there. And let's finish it from there to here. Okay. That would be good enough. Now, my suggestion to you is take use of those inner circumferences, so we can get ourselves a wonderful combination that serves us, like, for instance, rings that are intersecting one another. For instance, we could draw here this little ring here that starts from here to there. But on the other hand, let's assume we are going to get that ring here, but a smaller ring that goes from here, for instance, to there with this same radius. I get myself something like this. Okay, that is going to be also at the same time the one that finishes here. Good. And then those ones here, this one is going to continue on till it finishes. Oh, not that good, isn't it? So again, from here exactly there, open this one till it finishes there, and then it continues on here. Good. And that would be it, since I just need that one finishing precisely there. Oh, I forgot about this other one. It goes from here to there. So that would be, so you have a beautiful oval with two rings that are, as you can see, intersecting, interlacing each other. Okay, and that would be our third exercise this week. Thank you so much, and join me for the fourth and final exercise.